Hello again, everybody, and welcome back. We've been talking about work this chapter, and work being force times distance times the cosine of the angle phi. And if you recall, the angle phi is the angle that exists between the direction of motion and the force that's applied. But what if you have an angle greater than 90 degrees, an angle of phi greater than 90 degrees? What does this do? What this does is this produces negative work. Because let's say you have a box that is moving in direction D right there. All right, so here's your box and it's moving in direction D, but somebody is maybe standing in front of it, and I'll try to draw a little guy right here. This guy is standing in front of it, applying a force maybe upwards into an angle, a lot like the red line that's drawn right there. So he's applying a force, kind of like that. All right, the box is still moving in this direction, still moving towards the right. Okay, but what's his efforts? What are his efforts doing? Well, he's causing the box to slow down. He's pushing against it. He's applying a force in direction F right there, but the box is still moving this way, so he's doing negative work on this box. So this is what happens if you have a force that's applied at greater than 90 degrees from the direction of motion. So right here, straight up, there's your 90 degrees. Now let's just say for a minute if the object is moving horizontally and you're applying a force straight up, vertically right there. Does that do any work? No, it doesn't, right? Because the cosine of 90 degrees is 0. And just like we saw, let me flip back real quick, with our ant, right? If an ant applies a force up but moves in that direction, he's doing no work because the cosine of that angle is 90. That angle is 90 and the cosine of it is 0. But if you have that is greater than 90, well, what is this angle right here? Let's just make up an angle. Right? It's I'll do it in green. It's greater than 90, obviously, but it's less than 180. Let's say that it is, 135 degrees, okay? 135 degrees. What's the cosine of 135 degrees? Well, it's going to be negative something. It's the cosine is giving you the x component or the adjacent component, and so it's giving you this right here, that distance. And that would be a negative distance if you call this your origin. So this f at an angle greater than 90 degrees causes your work to be negative, or causes you to be doing negative work on this object. So this box is moving towards the right, but the guy is applying a force kind of to the left and up a little bit. He's doing negative work on this box. So if this box was originally moving, his efforts are going to be causing it to slow down. So anything greater than 90 degrees results in an applied force being in sort of the opposite direction of the displacement. That's what produces negative work. So our angle phi is going to be very important. Incidentally, we mentioned that it's the smaller of the two angles between the direction of motion and the force right here. Where's the other angle? Well, it's from here all the way around to there. All right, so from there to there, obviously that's a bigger angle than this. So this is the smaller of the two angles, even if it is 135 degrees. But the angle can't be any greater than 180 degrees, because let's just pretend for a minute that our force was right here. All right, you can't have greater than 180 degrees on the top right here, because that would mean that this down here on the bottom would be less than 180 degrees. It's always the smaller of the two angles, and so at the very maximum, the force can be 180 degree opposite direction from the direction of motion right there. So the biggest angle right here is going to be 180 degrees. By the way, what is the cosine of 180 degrees? Well, that's going to be -1. All right? If your force is totally in the opposite direction of your direction of motion, then you're going to have all that force, -1 times that force, doing work. So you're going to be doing all that force in the negative direction. So that's what negative work is all about. And so we need to keep in mind our angle phi right here and what direction our force is being applied with regards to the direction of motion. Now let's talk a little bit about net work. In the previous chapters, we talked about net something else, and that was net force. Because that means the sum of all the forces. Well, the same thing can be true with work. The nice thing about work, though, is that it is it's a scalar, and even though it can be negative, we're going to draw them as being kind of all added up right here. All right, so the total work that is done is a sum of all the works. Work 1 plus work 2 plus work 3, etc. Some of these can be positive. All right, some of these can be negative, so plus, if you put a negative in there, maybe work 3 is negative, that's going to be the total work done on an object. So you might have a person, there's a box right here, all right, and they're applying a force with their really long arms in this direction, so FA, or force applied, and it moves some distance d. Let's draw that in blue, all right, so it's d right there, that distance, I should say, that's distance d, okay. Well, what's some force that could be acting in the negative direction? What force acts against the direction of motion? I'll do this in black, I guess. Or you might be thinking friction, right? Friction always acts in the opposite direction of motion. You might say 180 degrees opposite direction of motion. So that kinetic friction is our other force. So you've got this work, the work of force applied times this distance, and then you've got the work of this friction force times this distance, but 180 degrees opposite. So these create all these different works that we can add up together to get the net work on that object. So we'll find the work from one force, and the work from another force, and the work from the third force, add them all up, and that gives us our net work. And that's going to be what the first part of our next example is going to be, example 8.4. I'll leave that for the next video segment, so I'll stop right here, but be sure to pick up example 8.4, and we're going to calculate all the individual works, and then add them up to get the net work. We're also going to be doing it a different way after that, which you may find, you might find easier, you might find harder, but it does have its purposes. So anyway, look for example 8.4a, and then I'll see you back here for doing network a different way. Thanks. I'll see you then.